If you're anything like me, you also probably hate hacking on Windows web applications, not because they're not vulnerable, but mostly because they are a pain to deal with. And there's so many techniques that could work on these web applications that it's just an endless cycle of things to test. But one of the most common ways to break into a Windows web app is the file enumeration vulnerability that's come out by Suresh Jalali, or also known as IRSDL. And just seeing that is kind of confusing because there are tools that actually get the job done, but you have to know how to use the tool's output to be able to exploit them. And honestly, I had no clue how to do this until about a year and some change ago, where a friend of mine, Renz, brought me this vulnerability to work on it. And then I reached out a couple of friends like Shubs, and we kind of figured it out all together. And I learned a lot from that process. And I took all of that learning and then kept on going after more and more Windows web apps until I had a solid understanding of how to actually exploit this vulnerability type. While I may just have learned about hacking these web apps better, I don't know how to create a Windows web application to a way where I could create a lab to make it accessible for you guys. But I've found a little bit of a hack around it. So I'm gonna kind of walk you through the entire process, then show you the lab and how it works, and then eventually show you just the entire vulnerability that came with it. So there's gonna be two parts to this video. The first part is the Windows part, where you find the files and you go at it. And then the second part is the actual web app vulnerability that I've created with a different stack. I'm going to explain as we go. But before we do this, this is how the output of ShortScan looks like when you find an IIS version that is vulnerable to the file enumeration vulnerability. The way this works is in a very short way, and the way I explain to others is the vulnerability allows you to see the first 6 letters of a file. So if the file is 20 letters long, you have to figure out the next 14 characters if you want to access that file. And it also tells you the extension, but it only gives you the first 3 letters of that extension. So if it's a file like config, instead of showing you config, it is just going to show .con. And if it is a folder, then obviously there's not going to be any extension. You just got to know it is a folder. All that will make sense as soon as we jump into our lab, but I want to make sure I explain this before we move forward. And a lot of times, one of the things that's really cool about this vulnerability type is a lot of people see an IIS default page, or they see some IIS web application and then just move on. They don't do anything. You can do a directory brute force, but some of these file names are a lot more complicated. But having the first 6 letters and the extension really does help you to understand, hey, if this is a zip file, for example, could it be a backup? Could it be a source code? Could it be X, Y, and Z? And then you kind of have to draw conclusions and see if you can access it. If it's an ASP file or if it's an HTML file, then if it starts with ADMIN, it's an admin file of some sort, making it's admin user, admin edit, whatever that is. And you have to kind of put those together and figure it out, which I'm hoping to show you in this video. But before I jump into the video, quickly, I gotta pick a bone with you guys and ask you for a favor. Roughly about 30% of you are not subscribed to the channel. And if you all hit that subscribe button down below on this video, it would get us closer to 200,000 followers and subscribers on this channel. And also, if you're watching this and you want to just help me out, do me a favor, hit that like button on the video and drop me a comment. This would help us reach more people and obviously would help us grow the channel as well. But all right, let's jump into the video. So when you do a scan, this is the tool that I use. It's called ShortScan by Bitquark. It's one of the best ones to use. And this is just a web app that I put together for this video. And when you launch the scan, all it's going to do is it's going to look at what version of IIS it is. It's going to do a couple of tests and tell you whether or not it's vulnerable. The next stage is, just because it's vulnerable doesn't mean that it's going to have files on there. So if there are any files on there, then it's going to try and tell you, hey, these are the first 6 that I was able to find. So if it's hidden, there's no extension here, it means that, hey, I did find a folder potentially, but I don't know what the rest of them are. I can assume in some cases, like here, you can see that it knows ASP.NET is probably ASP.NET_client, which is the default folder for its applications. And then sometimes it does make some conclusions. Like this one is templates. It's going, okay, it's very close to templates. So it could be templates, and I confirmed it. It could be templates 1, 2, 3. If that was the case, then that would not show up as here. And then obviously this is the index HTML. It's confirmed it exists, and so on. This is what it gets really interesting, because we have a ton of files here. We have the admin something.asp. We have something template. That's another folder, it looks like. We have a private doc. So it's saying private, but the E is missing. We can assume it means private, but there are some other stuff in there. There is a secret, another secret folder, requirements. I'm assuming this is requirements.txt for a Python app. There is a backup of some sort that probably has a .sql file. User, maybe that's user password, user pass 2024, 2025. and then there's a database and API something, and this is probably API credentials.config or API credentials file, whatever that is. But we need to figure out what these are while we are looking at them, right? It's just, I'm drawing conclusions based on everything that I know because I've created this application. But a lot of times it's just based on your experience, all the different things you have seen on other bug bounty programs. Maybe you can leverage AI and it could give you the file names for these ones that you can see based on the files that are actually available on the web server, or just you're using some tool to fuzz for these, which is also another way of doing this. So that's in a nutshell how this tool works, but let me show you what it looks like in the background when you're running this. So obviously, as an attacker, we don't get to see these, but this is kind of what it looks like when you are looking at the files that you want to guess, right? This first one was internal something, it's internal tools folder. This one is administrator panel.axp. This one was API credentials.config. Our goal is to be able to just kind of guess what are these files based on everything that we see here, right? Sometimes you may be lucky, and that's going to be the second part of this video, is you may get some sort of a zip file that has the data for everything in it, right? And you can just get the file names if you guess that zip. The thing that's really important here is not to go after every single one of these files because, for example, this private folder or this template one aren't going to be interesting, but if you prioritize a zip file, that could be a backup. If you prioritize the admin one that says, admin something right here on the screen, let me show it to you right here, then you're unlocking a new area of that application that you wouldn't have access to originally. Quickly, before I do the lab and show you the hands-on part of this video, I want to make a note and say, I created this application in Python because it's a lot easier for me to do it versus going and learning how to do these in Windows and then getting a Windows application up and running and figuring out all the configuration that comes with it for our platform. I'm not there yet, but I did make this in Python and I made it as close as I can to the actual vulnerability that I found in this company that I was hacking on. So keep that in mind. If you want to do it on your own, there will be a file down below. You can download it, run it on your system. I don't recommend doing it on your system, but that's up to you. Or you can just go and launch an EC2 instance for, I think the free tier allows you to do it. Just launch it on there on your own and try it out. And if I get enough comments, maybe I will make a private video on how to set this up as your environment and lab and link it down below in the comments at some point. So let me know in the comments and I'll get to it. But now let's just jump into the video and show you what the heck do we do once the short scan comes back and gives us a report. As a part of this lab, we're going to give you the short scan report that looks like this. It is going to have everything that you need. You don't have to run it. If you want to practice this, obviously a lot of vulnerability disclosure programs and bug bounty programs have outdated IIS and vulnerable IIS version that you can find and run short scan on. But for the sake of this report will be attached to the lab on Hacking Hub. If you want to follow along, go to Hacking Hub and look for the lab that has a keyword IIS in it, or just look at the pinned comments, it'll be there as well. But this is the output that I was given, very similar to this, when I was hacking on this bug bounty program that I cannot name. So what I had to do here is take a look at all these different files. That's a lot of files that we have to go after. Some of these are really good. Like if I could get access to the backup SQL file, great. If I wanted to get access to the private file, sure. Administrator, all those were great, but none of them work. And the thing that stood out to me was this zip file. The one that I found was not a zip file, it was a DLL file because it's a Windows application and that's what the source code was. But in this case, we have a zip file. I wanted to figure out what the heck is this zip file, because if I get access to this zip file that has something in it, hopefully it's a backup, hopefully it's a source code, hopefully it's something that I can use, then probably I could find more vulnerabilities than just reporting this IIS short name on its own, because that's not a vulnerability on its own because there's no impact there. But if I find the source code, I can audit it, look for multiple vulnerabilities, and then report it back to them and get a bunch of reports in. I went through all of these, none of them work. The focus point here becomes this right here, API something.zip. And we have API 202. The assumption here becomes that this is probably the year of this API being created. And I'm going to lowercase all of these just to be safe, even though in Windows that doesn't make a difference. But we're looking for API 202 blank. And we don't know what the heck that is. And we know that there is a zip file here. So it says .zip. We need to fill up the blank here. So here's what I'm going to think. I am going to create a file for just sake of this example and call it iis.txt. And we're going to talk about the logic of what you can do. Obviously, go to AI, tell it, hey, I have this file. It's a short name vulnerability. Give me a list of files I can try. Easy peasy. That's what I did, and it worked in my favor. But you have to know the logic behind it before you can do that. So if we're looking at API 202, the assumption here is that it's a year. So I'm going to start with 23, 24, 25, and since it's 2026 now, we're going to put 26 in there. That's got to be one of those, right? This is a good enough example for me to go after. I'm going to take 26 out because I know it's not 26, but a year or two before is fine as a good start. So this is what I want to go after, right? Now, we know it's called API, right? And I want to make this lowercase because in a Windows machine doesn't matter, but in Linux it does. So if I'm looking at API, what is it that could be a zip file? It could be a backup. So I'm going to just do backup. It could be source. It could be backups. It could be old. It could be anything that a developer could have uploaded to the server and could have some names around the API itself. So it could be API, maybe source code like this. It could be source code. And all of these other ones could be backup, source, package, and so on, right? These are just the things that you want to assume that exist there and want to try them out. This we don't care about. I'm going to take this out and we're just going to try this with our fuzzer. So what I'm going to do now here is I'm going to use ffuff and I'm going to do localhost. You can use the URL from the application on Hacking Help for this one and replace it. But I'm going to say API 2023 and I'm going to give this as a -u for our URL for ffuff. And then for the words that I'm going to try, I'm going to get is.txt. And we're going to put the word fuzz right after this. So our assumption, the first assumption here is that it's a 2023 file, and we're going to run this and see what comes back. What did I do wrong? It looks like the W is there, the U flag. Oh, I put an I instead of a U. So if I do this, it's going to come back and say nothing. We're going to do the same thing with 2024. Nothing came back. And then if we do 2025, nothing came back. And that is because we forgot the zip file for it. Damn it. So we forgot the zip file. So let's do it one more time. We're going to do the same thing here. We're going to go back up. Oh, wait, hold on one more time. That's not the right screen. Oops. So we forgot the zip file. So we're going to go back one more time. I'm going to do 2023 fuzz. It's really important that you do put the extension there. I've made that mistake so many times and you guys get to watch me do it again. We're going to do it with 2023, 2024. I think 2025 should work. And we can see now we have a file with this size, which is a larger file with a 200. And obviously, if you do an AC with a color, I think it's AC or C maybe, we can see that's colorful. Source code is there. So now we know the fuzz has to be replaced with source code. And if we do a curl, we can see that this file exists now. So I'm going to do API and then source code .zip. And I'm going to do a -o backup.zip, for example, so we can download it. And if I open this folder, and if we do it one more time, we have our file here, which allows us to get the source code access to this file. The key thing here was getting access to this. Obviously, with a Python file, everything is in one. With a DLL file, it was a little bit more messier, but we have everything. We have the config.py, so let's just see what that looks like. So if I go into the folder for this backup and do config.py, we can see there are some values here. Nothing really interesting, but what's really interesting for us is this right here. We have an API username and password, and that is exactly what I got originally based on the vulnerability. It gave me the assumption where I could get the username and password for the specific API, and now I can go to the website and see if these credentials work. So now what we have to do is quickly go back, and now we know what the username and password is in here, and it's allowing us to authenticate to this app. So we're going to quickly just make an authorization header by just doing an echo-n, and we're just going to give it a username and password. So our username here is, this is our username, our password, and we're going to feed that to base64 to get an encoded value for it. And now that we have this, all we have to do is just make sure we do one more time of this. Let me just do a base64-d. So it looks like, whoops, I took one out. So this should in reality work, API services. But it looks like it's missing, actually. We're missing something in the password, and that's the exclamation point. And I'm going to run it with the right username and password. We're going to get our token here. And now I could do a curl, and I've already done this. It's going to replace this value because I changed it. And if we go to our browser, remember it says authentication missing because we didn't have this header. I think now if we got everything right, we can see that now we're able to actually access this API and go through with the rest. I'm going to stop the video really quickly here because there is a vulnerability here with the file upload that allows you to get remote code execution but I don't want to ruin it by just simply giving it to you and just feeding it to you. So last step, if you want to try it out, it is on Hacking Hub, go try it out. But I did want to walk you through my process of how do I approach IIS applications? What do I do when I see an enumeration or a file and path enumeration vulnerability exists in an application? How do I just try and find the right file and enumerate for them? What does it look like in the background? And kind of show you one of my favorite vulnerabilities that I found using this technique. So if you want to try it out, go to Hacking Hub. It's free. You don't have to pay for anything. All you have to do is sign up. There's a link down below in the description. You can try it out. If you capture the flag, you will get some points and things like that as well. All right, that's it. Do me a favor. If you haven't already, hit that like button, drop me a comment, help us get to 200,000 subscribers. We're almost there, and I will see you all in next week's video. Peace.